Yes, in the last class, we have studied about the electrostatic potential, definition of electrostatic potential, and electrostatic potential difference. The work done in bringing the unit positive charge from infinity to that point against the electrostatic force of the field is called as an electrostatic potential. The potential difference between the 2 points is expressed by electrostatic potential difference. Based on that, today's session I will start with a new derivation, very important 5-mark question or a derivation. Define electrostatic potential, arrive the expression for potential due to an point charge, very important 5-mark question. For that, we have taken one diagram, in that the first one. Consider the source charge. Q is considered as a source charge or a point charge that is considered in terms of an origin. Very important 5-mark question. Arrive the expression for potential due to a point charge along with the definition. 5 mark important questions. Derivation part ಎಷ್ಟು ಮಾರ್ಕಿಗೆ ಹೇಳ್ತಾರೆ ಕೇಳಿದ್ರೆ 4 ಮಾರ್ಕಿಗೆ ಹೇಳ್ತಾರೆ. 1 ಮಾರ್ಕ್ ಯಾವುದಕ್ಕೆ ಇರ್ತದೆ ಕೇಳಿದ್ರೆ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ನ ಡೆಫಿನೇಷನ್ ಗೆ 1 ಮಾರ್ಕ್ ಇರ್ತದೆ. ಫಾರ್ ದಟ್ ವಿ ಆರ್ ಕನ್ಸಿಡರಿಂಗ್. ಹಾಗಾದ್ರೆ ನಾನು ಇಲ್ಲಿ ಡಯಾಗ್ರಾಮ್ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. ಕನ್ಸಿಡರ್ ದ ಸೋರ್ಸ್ ಚಾರ್ಜ್. Q is considered to be a source charge that is also said to be a point charge that is considered at the origin, that is expressed by O. Let P be a point. ನೋಡಿ ಕ್ಯೂ ಇಂದ ಸೀದಾ ಒಂದು ಲೈನನ್ನು ಬರೆದಿದ್ದೇನೆ, ಇಲ್ಲಿ ಒಂದು ಲೈನ್ ಇದೆ. ಲೆಟ್ ಪಿ ಬಿ ಎ ಪಾಯಿಂಟ್ ಈಸ್ ಎಟ್ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಆರ್ ಫ್ರಮ್ ಓ. ದಟ್ ಪಾಯಿಂಟ್ ಪಿ is called as a potential point. That point P is called as a potential point. I repeat, the source charge Q or the point charge Q is placed at the origin is known as O. A charge, it possesses electric field, thus it exerts electrostatic force. Therefore, by using the unit positive charge at infinity, the work done is needed in order to get the potential. That potential point is expressed by P. ಹಾಗಾದ್ರೆ ನಮಗೆ ಪೊಟೆನ್ಷಿಯಲ್ ಅನ್ನುವಂಥದ್ದು ಬೇಕಾದರೆ ಏನು ಮಾಡಬೇಕು ಕೇಳಿದರೆ 1 ಕೂಲಂಬ್ ಚಾರ್ಜನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಇನ್ಫಿನಿಟಿಯಿಂದ ಒಂದು ಪಾಯಿಂಟ್ನ ತನಕ ಮೂವ್ ಮಾಡಿದ್ದಾನೆ. ಎಲ್ಲಿಯ ತನಕ ಮೂವ್ ಆಗಿದ್ದಾನೆ ಕೇಳಿದರೆ ದಟ್ ಪಾಯಿಂಟ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ P. Therefore, let P be a potential point is at a distance R from O. ಹಾಗಾಗಿ ಬರ್ದಿದೆ ನೋಡಿ, ಕನ್ಸಿಡರ್ ಎ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಪ್ಲಸ್ Q is at the origin O. Let P be a potential point is at a distance R, which means that work done in bringing the unit positive charge from infinity to that point against the electrostatic force of the field. Therefore, the point P in which the potential develops. Based on the we are done by the diagram. ಹಾಗಾಗಿ ಅದಕ್ಕೆ ಬೇಕಾದಂಥ ಎಕ್ಸ್ಪ್ಲನೇಷನ್ ಅನ್ನು ಇಲ್ಲಿ ಬರ್ತಿದ್ದೇನೆ. Now, consider some intermediate points in an electrostatic field line. That intermediate point is known to be A. Consider some intermediate point A at a distance x from O. Consider some intermediate point A is at a distance x from O. ಇಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನಲ್ಲೇ ಒಂದು ಪಾಯಿಂಟನ್ನು ಚೂಸ್ ಮಾಡ್ತಾ ಇದ್ದಾನೆ. ಇಟ್ ಮೀನ್ಸ್ ದಟ್ ಅದರ ಮೀನಿಂಗ್ ಏನು ಕೇಳಿದರೆ 1 ಕೂಲಂಬ್ ಆಫ್ ಚಾರ್ಜನ್ನು ನಾನು ಏನು ಮಾಡ್ತಿದ್ದೇನೆ ಕೇಳಿದರೆ ಇನ್ಫಿನಿಟಿಯಿಂದ ಹಿಡ್ಕೊಂಡು ಏನ ತನಕ ಬಂದಿದ್ದೇನೆ. ದಟ್ ಪಾಯಿಂಟ್ ಇಸ್ ಕನ್ಸಿಡರ್ಡ್ ಆಸ್ ಅನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪಾಯಿಂಟ್. ದರ್ಫೋರ್ ಕನ್ಸಿಡರ್ಡ್ ಸಮ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಪಾಯಿಂಟ್ ಎ ಎಟ್ ಅ ಡಿಸ್ಟೆನ್ಸ್ ಎಕ್ಸ್ ಫ್ರಮ್ ಓ. ದರ್ಫೋರ್ ದ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್. ಯಾವಾಗ ನಾನು 1 ಕೂಲಂಬ್ ಚಾರ್ಜನ್ನು ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಾಯಿಂಟ್ ಎಗೆ ಇಟ್ಕೊಂಡು ಬರ್ತೇನೆ, ಆಗ ಏನಾಗ್ತದೆ ಕೇಳಿದರೆ ಸೋರ್ಸ್ ಚಾರ್ಜಿಂದ ಎಕ್ಸರ್ಟ್ ಆಗ್ತಿರುವಂಥ ಫೋರ್ಸ್ ಏನಿದೆ, ಸೋರ್ಸ್ ಚಾರ್ಜಿಂದ ಕ್ರಿಯೇಟ್ ಆಗ್ತಿರುವಂಥ ಫೋರ್ಸ್ ಏನಿದೆ, ಆ ಫೋರ್ಸ್ ಅನ್ನುವಂಥದ್ದು 1 ಕೂಲಂಬ್ನ ಚಾರ್ಜ್ನ ಮೇಲೆ ಇರ್ತದೆ. Therefore, the magnitude of the electrostatic force on a unit positive charge at A is the magnitude of the electrostatic force on a unit positive charge. ನೋಡಿ ಇಲ್ಲಿ 1c ಅಂತ ಬರೆದಿದ್ದೇನೆ. ಮೀನಿಂಗ್ ಏನು ಕೇಳಿದರೆ 1 ಕೂಲಂಬ್ ಚಾರ್ಜನ್ನು ನಾನು ಇನ್ಫಿನಿಟಿಯಿಂದ ಎಲ್ಲಿಗೆ ಮೂವ್ ಮಾಡಿದ್ದೇನೆ, ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಾಯಿಂಟ್ ಎಗೆ ಮೂವ್ ಮಾಡಿದ್ದೇನೆ. ಯಾವಾಗ 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ಅನ್ನುವಂಥದ್ದು ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಾಯಿಂಟ್ ಎಗೆ ಬರ್ತದೆ, ಇದರ ಮೇಲೆ ಫೋರ್ಸ್ ಎಕ್ಸರ್ಟ್ ಆಗ್ತದೆ. ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ದ ಸೋರ್ಸ್ ಚಾರ್ಜ್ ಆರ್ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್. Therefore, that force is written by the term according to the Coulombs law. According to the Coulombs law, F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by R square ಅಂತ ನಾವು ಜನರಲ್ ಇಕ್ವೇಷನ್ ಅನ್ನು ಬರೆದಿದ್ದೇವೆ. Therefore, the distance here we are expressed by x. R square ನ ಡಿಸ್ಟೆನ್ಸ್ ನಾನು ಇಲ್ಲಿ ಹೇಗೆ ಬರೀತೇನೆ ಕೇಳಿದರೆ x ಅಲ್ಲಿ ಬರೀತಾ ಇದ್ದೇನೆ. Therefore, F is equal to 1 by 4 pi epsilon naught the one charge. The first charge is known as a point charge or a source charge Q. The second charge will be a unit positive charge, which means the charge is equal to 1 coulomb. ಹಾಗಾಗಿ Q2 ಅನ್ನು ಬರೆಯುವ ಬದಲು ಹೇಗೆ ಬರೆದಿದ್ದೇನೆ ಕೇಳಿದರೆ 1 coulomb 1 ಅಂತ ಬರೆದಿದ್ದೇನೆ. Therefore, force is equal to 1 by 4 pi epsilon naught Q into 1 divided by x square, which means that Q divided by x square. Is it clear? ಕ್ಲಿಯರ್ ಆಗಿದೆ ಅಂತ ಅಂದ್ಕೊಂಡಿರ್ತೇನೆ. ಜಸ್ಟ್ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದೆ ಕೇಳಿದರೆ ಇಲ್ಲಿಯ ತನಕ, ಸೋರ್ಸ್ ಚಾರ್ಜ್ ವಿಚ್ ಎಕ್ಸರ್ಟ್ಸ್ ದ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್, ದಸ್ ಇಟ್ ಎಕ್ಸರ್ಟ್ಸ್ ಅನ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ up to infinity. The infinity in which we are taken by the unit positive charge is called as a plus 1 coulomb. That is bring from the point is known as an infinity to A. When the same unit positive charge, when it brings from infinity to A, it experiences the magnitude of the electrostatic force. According to the Coulombs law, we are written by that force is known as F is equal to 1 by 4 pi epsilon naught Q into 1 divided by x square. Now the same 1 coulomb charge, now it is displaced, now it is moving against the electrostatic force. Now 1 coulomb of charge that are taken from the point is known as an A to B through a distance is called as an dx. Thus it requires an external force. ಯಾವಾಗ 1 coulomb charge ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಪಾಯಿಂಟ್ ಎ ಇಂದ ಬಿಗೆ ಮೂವ್ ಆಗ್ತಾ ಇದ್ದೀರಿ, electrostaticನ ಫೋರ್ಸ್ನ ವಿರುದ್ಧ ಮೂವ್ ಆಗ್ತಾ ಇರುವಂತದ್ದು. Thus there is an external work done. Therefore the small amount of work done, ನೋಡಿ ಇಲ್ಲಿ ಸೆಂಟೆನ್ಸ್ ಆಗಿದೆ ನೋಡಿ, small amount of work done in moving a unit positive charge from A to B. 1 coulomb of charge that I bring from the point is known as now A to B. 1 coulomb of charge ನಾನು ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ತರ್ತಾ ಇದ್ದೇನೆ ಕೇಳಿದ್ರೆ from the point A ಇಂದ B ಗೆ ತರ್ತಾ ಇದ್ದೇನೆ. Through a distance there is a displacement through the charge. It is independent of the path. Path ಅನ್ನು ನಾನು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇಲ್ಲ. Without an acceleration ಸಹ ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇಲ್ಲ. ಜಸ್ಟ್ ಎಕ್ಸ್ಟರ್ನಲ್ ಫೋರ್ಸ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಿಕೊಂಡು 1 coulomb of charge ಅನ್ನು A ಇಂದ B ಗೆ ಡಿಸ್ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೇನೆ. Therefore small amount of work done in moving a unit positive charge from the point A to B through a small distance dx is, therefore there is an amount of work done. That small amount of work done is expressed dw. Work done is on a scalar, therefore work done is equal to, change in work done is equal to F vector dot, here it is the dot product, F vector dot dx vector is the displacement, that is equal to dot product is replaced by the function is called as a cos. ಇಲ್ಲಿರುವಂಥ ಟರ್ಮ್ ಅನ್ನು ನಾನು ಇಲ್ಲಿ ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಅಲ್ಲಿ ಬರ್ತಿದ್ದೇನೆ. Therefore dw is equal to F vector dot dx vector in terms of a magnitude that is expressed by F dx cos theta. Therefore equations ಅಲ್ಲಿ ಏನು ಡೌಟ್ ಇಲ್ಲ ಅಂತ ಅನ್ಸ್ಕೊಳ್ತೇನೆ. The reason is that 1 coulomb of charge that are bring from the point is known as A to B through a distance is called as an dx. Therefore there is a small amount of work done. Work done is nothing but force into displacement. Therefore F vector dot dx vector is equal to F dx cos theta. Is it clear? Now theta is equal to the theta be the angle. See here the direction of the force. The direction of the force is from along the direction is OP. Force na direction hegide kelidre, the force which are exerted along the direction is known as an OP, but the unit positive charge is moving opposite to the direction of the force. Unit positive charge hege move ಆಗ್ತದೆ ಕೇಳಿದ್ರೆ force na opposite direction ಅಲ್ಲಿ move ಆಗ್ತಾ ಇದೆ. Therefore the angle between the force, electrostatic force, as well as the displacement or the distance traveled by the 1 coulomb of charge from the point is known as an A to B is opposite. Therefore the angle between them, it is not zero. ಎರಡು ಒಂದೇ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಇದ್ರೆ ಮಾತ್ರ ನಾವು 0 ಅಂತ ಬರಿತೇವೆ. ಸಪೋಸ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಹೀಗೆ ಇದೆ, 1 coulomb of charge ಅನ್ನು ಸಹ ನೀವು ಸೇಮ್ ಡೈರೆಕ್ಷನ್ ಅಲ್ಲಿ ಮೂವ್ ಮಾಡಿದ್ರೆ ದ ಆಂಗಲ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಡಿಗ್ರಿ. ಆಂಗಲ್ ಥೀಟಾ ಇಸ್ ಈಕ್ವಲ್ ಟು 0 ಡಿಗ್ರಿ. ಬಟ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ದ ಫೋರ್ಸ್ ಇಸ್ ಲೈಕ್ ದಿಸ್ ಅಲಾಂಗ್ OP, ಬಟ್ 1 coulomb of charge is moving opposite to the direction of OP. Therefore the angle between them is equal to theta is equal to 180 degree. Very important one, where theta is equal to 180 since the direction is opposite to the direction of electrostatic force. Therefore the same equation is considered as dw is as usual F times of dx cos 180. The value of cos 180 will be minus 1. Therefore the same equation is written as dw is equal to minus F times of dx. The reason is that cos 180 will be minus 1. Therefore that is equal to, the value of F is equal to, according to the first equation, the value of F is equal to 1 by 4 pi epsilon naught Q times of 1, that is Q divided by x square, that I substituted here. Dx is as usual. ಇಲ್ಲೇ ತನಕ ನಿಮಗೆ ಟರ್ಮ್ ಅರ್ಥ ಆಗಿದೆ ಅಂದ್ಕೊಳ್ತೇನೆ, ಮುಂದೆ ಬರ್ತೇನೆ. Therefore the total work done in moving a unit positive charge, here it is a change in work done. Here it is a change in work done. Therefore the total work done in moving a unit positive charge from infinity to the point P is, infinity in the point P ಬರೋ ತನಕ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ ಅನ್ನು ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ದೀರಿ. Here we are calculating the work done in between the point is known as an A to B. ಇಲ್ಲಿ ನಾನು dw ಅಂತ ಏನು ಬರೆದಿದ್ದೇನೆ, that work done is considered from the point is known as an A to B. ಯಾವಾಗ 1 coulomb of charge ಅನ್ನು ನಾನು A ಇಂದ B ಗೆ ಮೂವ್ ಮಾಡಿರುವಂಥದ್ದು, A ಇಂದ B ಗೆ ಮೂವ್ ಮಾಡೋದಕ್ಕೆ ಬರೆದಂಥ ವ್ಯಾಲ್ಯೂ ಏನು ಕೇಳಿದರೆ dw. Now the same 1 coulomb of charge that I bring from the point is known as an infinity to P. therefore that is considered as a total work done. ಹಾಗಾಗಿ ಇನ್ಫಿನಿಟಿಯಿಂದ ಪಿಗೆ ಮೂವ್ ಆದಂಥದ್ದು ನಾನು ಹೇಗೆ ಬರೀತಾ ಇದ್ದೇನೆ ಕೇಳಿದರೆ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಅಲ್ಲಿ ಬರೀತಾ ಇದ್ದೇನೆ. therefore total work done in moving a unit positive charge from infinity to the point P is W is equal to integration of dW, the sum of work done. ಹಾಗಾಗಿ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೇನೆ. sum of work done, therefore integration of dW is equal to, integration is expressed by infinity to R. dW will be minus 1 by 4 pi epsilon naught q divided by x square dx. In that 1 by 4 pi epsilon naught is common, constant. Q is also a constant since it is in a source charge or in a point charge. Therefore, which one be the variable? The variable will be 1 by x square. ಯಾಕೆ ಕೇಳಿದರೆ 1 by 4 pi epsilon naught q ಅನ್ನುವಂಥದ್ದು ಕಾಮನ್ ಟರ್ಮ್. ನಾವು ಕಾನ್ಸ್ಟೆಂಟನ್ನು ಏನು ಮಾಡೋದಿಲ್ಲ ಕೇಳಿದರೆ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡೋದಿಲ್ಲ. ಏನು ಮಾಡ್ತೇವೆ ಕೇಳಿದರೆ ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿ ಹೊರಗಡೆ ಬರೆದಿದೆ ನೋಡಿ, ಮೈನಸ್ ಕ್ಯೂ ಡಿವೈಡ್ ಬೈ 4 pi epsilon naught is taken as a constant. Therefore the integration limit is from infinity to r 1 by x square dx. Therefore W is equal to minus q divided by 4 pi epsilon naught. The integration of 1 by x square is the basic formula, that will be minus 1 by x. The limit ನೋಡಿ, ಇಂಟಿಗ್ರೇಷನ್ ಆದ ನಂತರದಲ್ಲಿ ಪುನಃ ನೀವು ಇಂಟಿಗ್ರೇಷನ್ ಸಿಂಬಲ್ ಅನ್ನು ಇಡಲಿಕ್ಕಿಲ್ಲ. ಇಂಟಿಗ್ರೇಷನ್ ಮಾಡಿದ್ದೇನೆ, ದ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ 1 by x square is equal to dA, 1 by x square dx is equal to minus 1 by x. ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್, ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿ. ಇಲ್ಲಿ ಮೈನಸನ್ನು ಕಾನ್ಸ್ಟೆಂಟ್ ಆಗಿಟ್ಟು ಹೊರಗಡೆ ಬರೆದಿದ್ದೇನೆ. ದಟ್ ಇಸ್ ಮೈನಸ್ ಕ್ಯೂ ಡಿವೈಡ್ ಬೈ 4 pi epsilon naught. ದ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ 1 by x square dx will be minus 1 by x again. That is a constant term. ಇಂಟಿಗ್ರೇಷನ್ನ ಒಂದು ಕಾನ್ಸ್ಟೆಂಟ್ ಟರ್ಮ್ ಇಂಟಿಗ್ರೇಷನ್ನ ಕಾನ್ಸ್ಟೆಂಟ್ ಟರ್ಮ್ 1 by x square dx ಅಂತ ಹೇಳಿದರೆ minus 1 by x. ಆಫ್ಟರ್ ಇಂಟಿಗ್ರೇಟಿಂಗ್ ದ ಇಕ್ವೇಷನ್ we are taken in terms of a square bracket. ಒಂದು ಸಲ ಒಂದು ಫಂಕ್ಷನನ್ನು ನೀವು ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಿ ಆದ ನಂತರದಲ್ಲಿ ಪುನಃ ಇಂಟಿಗ್ರೇಷನ್ ಸಿಂಬಲ್ ಅನ್ನು ಯೂಸ್ ಮಾಡಲಿಕ್ಕಿಲ್ಲ. ಹೇಗೆ ಯೂಸ್ ಮಾಡಿದ್ದೇನೆ ಕೇಳಿದರೆ ಇನ್ ಟರ್ಮ್ಸ್ ಆಫ್ a square bracket. therefore the lower limit will be infinity, the upper limit will be r. therefore upper limit minus lower limit. ಇಲ್ಲಿ ಯಾವುದು ವೇರಿಯೇಬಲ್ ಇದೆ, which one be the variable? x be the variable. ಹಾಗಾದ್ರೆ ಆ ವೇರಿಯೇಬಲ್ಗೆ ಏನು ಮಾಡಬೇಕು ಕೇಳಿದರೆ ಬೈ ಸಬ್ಸ್ಟಿಟ್ಯೂಟಿಂಗ್ ದ ಲಿಮಿಟ್ಸ್, ಅಪ್ಪರ್ ಲಿಮಿಟ್ ಮತ್ತು ಲೋವರ್ ಲಿಮಿಟ್ ಅನ್ನು ಏನು ಮಾಡಬೇಕು ಕೇಳಿದರೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. therefore minus of minus will be plus q divided by 4 pi epsilon naught as usual. ಹೇಗಿದೆ ಹಾಗೆ ಬರೆದಿದ್ದೇನೆ. in the place of x we are written by 1 by r minus lower limit 1 by infinity. 1 by infinity will be 0. therefore work done is equal to 1 by 4 pi epsilon naught, ಕಾಮನ್ ಆಗಿ ತೆಗೆದಿದ್ದೇನೆ, q into 1 will be q divided by r. therefore the total work done when the unit positive charge is bring from the point infinity to the point P is given by work done is equal to 1 by 4 pi epsilon naught q divided by r. Is it clear? Based on that, by the definition of work done, which means by the definition, work done is equal to, since in the last class we have studied about the electrostatic potential mathematical way. ಲಾಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಪೊಟೆನ್ಷಿಯಲಿಗೆ ಮ್ಯಾಥಮೆಟಿಕಲ್ ವೇಯಲ್ಲಿ ಒಂದು ಇಕ್ವೇಷನ್ ಅನ್ನು ಬರೆದಿದ್ದೇನೆ, ವಿ ಇಸ್ ಈಕ್ವಲ್ ಟು ಡಬ್ಲ್ಯೂ ಡಿವೈಡ್ ಬೈ ಕ್ಯೂ ಅಂತ. Potential is equal to work done by unit positive charge. V is equal to W divided by Q. Therefore, W is nothing but potential. By the definition, therefore, work done is equal to the electrostatic potential V is at the point P. I repeat, by the definition, work done is equal to the electrostatic potential V. Work done is equal to electrostatic potential V is at a point P. In bringing the unit positive charge is from infinity to the point P. Therefore, this work done is considered as a potential according to the definition. Therefore, V is equal to, W and V in the replace ಮಾಡಿದ್ದೇನೆ according to the definition. Therefore, V is equal to 1 by 4 pi epsilon naught Q divided by R. Is it clear? Hence the proof. ಹಾಗೆ ಹೇಳಿದರೆ arrive the expression for potential due to a point charge. We are getting the expression for potential due to a point charge. Point charge will be Q. ಇಲ್ಲಿ ಸ್ಮಾಲ್ ಕ್ಯೂ ಅಂತ ಬರಲಿಕ್ಕಿಲ್ಲ ನೋಡಿ, ಕ್ಯಾಪಿಟಲ್ ಕ್ಯೂ ಹೇಳ್ಕೊಂಡಿದೆ, ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಆರ್ ಎ ಸೋರ್ಸ್ ಚಾರ್ಜ್. therefore V is equal to 1 by 4 pi epsilon naught Q divided by. Hence the proof. Very important 5 mark question along with the definition. Define electrostatic potential 3 to 4 time repeat ಆಗಿದೆ, ಸೇಮ್ ಕ್ವಶನ್ ಅನ್ನುವಂಥದ್ದು 3 to 4 time repeat ಆಗಿದೆ. Define electrostatic potential 1 mark. Arrive the expression for potential due to a point charge. Hence the proof. ಇಲ್ಲೇ ತನಕ ಪ್ರೂಫ್ ಮಾಡಬೇಕು. ಇಲ್ಲಿ ಒಂದು ಹೊಸ ಟರ್ಮ್ ಏನು ಕೇಳಿದರೆ ಇಂಟಿಗ್ರೇಷನ್ ಆಫ್ ಇನ್ಫಿನಿಟಿ ಟು ಆರ್ 1 by x square dx, ದಟ್ ಇಸ್ ಕಾನ್ಸ್ಟೆಂಟ್. 1 by x square dx will be a constant. As potential due to a system of charges, a group of charges is known to be a system of charges. Q1, Q2, Q3 and so on Qn. These charges are said to be in a system of charges. Therefore, consider a system of charges Q1 is at a distance r1 from P. Q2 is at a distance r2 from P. Q3 is at a distance r3 from P. as so on, Qn is at a distance Rn from P. Therefore, the potential at a point P is due to the charge is known as an Q1. This charge is known to be point charge. ನಿಮಗೆ ಡೌಟ್ ಬರ್ತದೆ, ಆಲ್ರೆಡಿ ಫಸ್ಟ್ ಡ್ಯೂರೇಷನ್ ಬರೆಯುವಾಗ ಸ್ಮಾಲ್ Q1 ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗಿ ತೊಗೊಂಡಿದ್ದೀರಿ ಸರ್ ಅಂತ ಅಲ್ವಾ. ಆ ಡ್ಯೂರೇಷನ್ಸಲ್ಲಿ ನಾನು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜನ್ನು Q ಅಂತ ಬರೆದಿದ್ದೇನೆ. ಇಲ್ಲಿ ನೀವು ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಆದ್ರಿಂದಾಗಿ Q1 Q2 ಅಂತ ಬರೆದಿದ್ದೇನೆ. ಅದನ್ನು ಕ್ಯಾಪಿಟಲ್ Q ಆಗಿ ಸಹ ಕನ್ಸಿಡರ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಅ ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಇದನ್ನು ಯೂನಿಟ್ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಆಗಿ ತಗೊಳ್ತಾ ಇಲ್ಲ. ಈಸ್ ಕನ್ಸಿಡರ್ಡ್ ಟು ಬಿ ಎ ಪಾಯಿಂಟ್ ಚಾರ್ಜ್ ಇಟ್ ಸೆಲ್ಫ್. Therefore, Q1 will be a point charge is at a distance is at a distance R1 from P. Therefore, the potential at P is due to the charge Q1 is at a distance R1. According to the derivation, V is equal to 1 by 4 pi epsilon naught. V is equal to 1 by 4 pi epsilon naught. Q divided by R is the general expression. Now, is due to the charge Q1, that potential will be V1 is equal to 1 by 4 pi epsilon naught Q1 divided by R1. As well as the potential due to the charge Q2 is at a distance R2 from the point P. That is V2 is equal to 1 by 4 pi epsilon naught Q2 divided by R2. Then the potential is due to the charge Q3 is at a distance R3 from the point P is given by, ಇಲ್ಲಿ ಬರಲಿಲ್ಲ, ಜಸ್ಟ್ ಬೇಕಾದರೆ V3 is equal to, by the general expression, V3 is equal to 1 by 4 pi epsilon naught Q3 divided by R3. Then the potential at P is due to the charge Qn is at a distance R1. Vn is equal to 1 by 4 pi epsilon naught. In the place of Q1, Q2, Q3, we are written by Qn, since is the n number of charges divided by Rn. Then, according to the superposition principle, the total potential at the point P is due to the system of charges. The total potential at a point P is due to the system of charges is given by V is equal to V1 plus V2 plus and so on up to Vn. By substituting, V is equal to 1 by 4 pi epsilon naught Q1 by R1 is the value of V1. The value of V2 will be 1 by 4 pi epsilon naught Q2 by R2 and so on, plus Vn value will be 1 by 4 pi epsilon naught Qn divided by Rn. In that, 1 by 4 pi epsilon naught is common in all the equations. Nodi, 1 by 4 pi epsilon naught is common. ಹಾಗಾದರೆ 1 by 4 pi epsilon naught ಅನ್ನು ಕಾಮನ್ ಆಗಿ ತೆಗೆದ್ರೆ ಏನು ಉಳಿತು? Q1 by R1 plus Q2 by R2 and so on plus Qn by Rn. Therefore, potential V is equal to 1 by 4 pi epsilon naught is as usual. Q1, Q2, Qn is expressed by the arithmetic progression that is known to be a Qi. Therefore, summation I equal to 1 to n. Summation I equal to 1 to n. Qi divided by Ri is the general expression for potential due to a system of charges. For a 3-mark question, here I will not write the explanations. You have to prepare the notes for that. Yes.